For 4 billion years, life has unfolded on Earth. But only in the last few million years did one species cross an evolutionary chasm, developing the capacity for self-reflection, mathematics, and philosophy. We rarely ask, what exactly is this thing we call intelligence? And why, given the sheer magnitude of time and complexity, is advanced cognitive ability so profoundly rare? This is not a story about how we won the evolutionary lottery. It's an investigation into the brutal physics and biological constraints that make complex cognition an emergent property, a series of lucky accidents built upon necessity. We need to define the fundamental currency of intelligence: survival through accurate prediction. The first great hurdle wasn't thought, but simply sensing. Single-celled organisms developed chemoreception, the ability to identify chemical gradients. That is the baseline of biological smartness. If you can distinguish nutrient from toxin, you possess proto-intelligence. The massive leap, the evolutionary bottleneck, occurred with the centralization of decision-making. The Cambrian explosion, 540 million years ago, gave rise to bilateral symmetry and the cephalization, the bundling of sensory organs and processing power at one end of the body. Why centralize? Because movement requires coordination. A jellyfish can afford a diffuse nerve net. A chasing predator cannot. Efficient movement demanded a master computer, a brain, to manage rapid sensory input and output across a long axis. But a brain is metabolically expensive. Our modern human brain accounts for only 2% of our body mass but consumes about 20% of our resting energy. Evolution does not tolerate such waste unless the payoff is immense. The cost-benefit analysis had to be revolutionary. This leads us to the critical environmental catalyst: variability. In stable, predictable environments, specialization reigns supreme. Intelligence is not needed. But when climates fluctuate wildly and resource patches shift, adaptability, the core function of intelligence, becomes the ultimate survival tool. Enter the primates. Social complexity was the next forcing function. For our hominin ancestors, the environment wasn't just physical but social. Knowing where resources were was important. Knowing what the dominant male or female thought was often the difference between life and death. The Machiavellian hypothesis suggests that the selective pressure for increased brain size wasn't solving technical problems, but solving social ones. Deception, alliance formation, and recognizing complex hierarchies required a massive upgrade in neural architecture, specifically the neocortex. Then came bipedalism. While initially beneficial for temperature regulation and traversing open savannas, it unintentionally freed the hands. This liberation created a positive feedback loop. Better dexterity allowed for better tool use. Better tools allowed for higher quality food. Higher quality food fueled larger, more energy-hungry brains. Tool usage isn't unique, but the teaching of complex tool sequences is. This required abstract thought and the fundamental ability to model the world outside our immediate perception. This external modeling capacity gave rise to perhaps the greatest evolutionary invention: language. Language is crystallized intelligence. It's not just communication, it's compression. We can share the equivalent of decades of experience in mere seconds, allowing knowledge to accumulate across generations, exponentially accelerating our cognitive landscape. This is cultural evolution outpacing biological evolution. The critical component of modern human intelligence is recursive thought, the ability to embed thoughts within thoughts. I think, therefore I am. But also, I think that she thinks that I think. This recursive capacity underlies complex planning, morality, and our unique sense of self. The final major acceleration, the Great Leap Forward, around 40,000 years ago, correlates less with new biology and more with environmental shifts driving cultural density. When populations hit certain thresholds, the exchange of ideas, innovation becomes inevitable. So, here we stand. A species whose intelligence is not the result of destiny, but a cascade of contingent environmental pressures, social demands, and biochemical luck. It's a solution optimized for a specific volatile planet in a specific time. But this optimization carries risk. The paradox of high intelligence is that the specialized mechanisms we developed for survival, tribalism, complex manipulation, rapid resource utilization, now threaten our planetary stability. Our analytical engine is running on firmware designed for the savannah, not the Silicon Age. The next stage of intelligence evolution won't be biological. It's externalized. We are rapidly building systems, artificial intelligence, that bypass the biological constraints that took us billions of years to overcome. We are creating the intellectual heir to Homo sapiens, often without understanding the foundational requirements that kept our own evolution ethical and grounded. The deep investigation into our evolutionary ascent teaches us this. Intelligence is not an end point, but a volatile process fueled by necessity. Understanding the fragility of that process is critical, because as we extend our minds into synthetic domains, the only remaining evolutionary pressure is the conscious choice of how we define smart moving forward. What do you think is the next great evolutionary leap for human cognition? Is it biological, synthetic, or a synthesis of both? Let me know your analysis in the comments below. If you found this journey through deep time and cognitive science valuable, please like and subscribe for more analytical explorations.